Here we have a problem on limits. That is, we have to evaluate limit extends to 2 sine pi x over 2 negative x. Okay, here what we can do is directly we can substitute the given limit for x. That is, we have to plug in 2 for x into the function. Then I'll be getting sine pi times 2 over 2 negative 2. So sine pi times 2 is nothing but 2 pi over 2 negative 2 is 0. So we can get the value of sine 2 pi from the unit circle. So the value of sine 2 pi is 0. So we get 0 over 0. Actually 0 over 0 is called indeterminate form. So this is called indeterminate form. So whenever we get indeterminate form like 0 over 0, it's not a final answer. So we have to apply L'Hopital's rule. So what is L'Hopital's rule? L'Hopital's rule is something about applying the step which comes right before where we have applied the limit. Actually, this is a step we have applied the limit 2 for x. You just consider the previous step. That is nothing but the question. So in this step, I have to apply L'Hopital's rule. So applying L'Hopital's rule means we have to find the derivative of this numerator and denominator with respect to the variable x, because we have limit for the variable x. Usually, when I find derivative of a function which contains variable in both numerator and denominator, I'll be using quotient rule. But when we apply L'Hopital's rule, we are not supposed to use quotient rule. We have to find the derivative of this one and this one separately with respect to the variable for which we have the limit. So here in this case, that is x. Okay, so let me apply L'Hopital's rule. So we have limit x tends to 2. So now, since I applied L'Hopital's rule, I have to find the derivative of the sine pi x with respect to x. So the derivative of sine pi x is cosine pi x. So far, I got derivative only for sine. By chain rule, I have to find the derivative of this pi x. When I find derivative of pi x with respect to x, what will happen? So pi is a constant multiplied by the variable. Whenever I find derivative of the product of two quantities where one is constant and other one is variable, so when I find derivative, I have to keep the constant as it is and find the derivative of the variable alone. Here the variable is x. When I find derivative of this x with respect to x, it will become 1. So pi times 1 is just pi. So the derivative of this pi x is just pi. So first I get the derivative of sine pi x, it's cosine pi x. So it's just a derivative of sine alone. So by chain rule, if I get the derivative of pi x, it's just pi. Okay, in denominator, so 2 is a constant. When I find the derivative of this 2, it will become 0. And the derivative of this negative x will become, the derivative of negative x with respect to x will be negative 1. Okay, so limit x tends to 2. So this pi can be written in front of the cosine x. Then I'll be getting pi times cosine pi x over 0, negative 1 is negative 1. Okay, so limit x tends to 2. So whenever the denominator is 1, it can be ignored and we can move this negative sign over here. I get negative pi times cosine pi x. Okay, that's all the simplification we can do over here in the function. So now what we can do is we can apply the given limit for x. That is, we have to plug in 2 for x over here. So when I do so, I'll be getting negative pi times cosine pi times 2. So negative pi times cosine pi times 2 can be written as cosine 2 pi. So we know that the value of cosine 2 pi is just 1. So negative pi times 1 will be negative pi. So the evaluation of the given limit is negative pi.